Hello everyone, this is Dr. T. Bhargava Ramu, Assistant Professor, Electrical and Electronics Engineering, MLR Institute of Technology, Hyderabad. Today we will discuss about AC and DC distribution system which comes under power systems. We will discuss today distributor fed at one end, distributor fed at both ends with equal voltage, with unequal voltage. So in today's topic, so these are the different types of loading of distributor, which is variously we can categorize with equal voltage on both ends, with unequal voltage on both ends, and uniformly loading system, concentrated loading system. So these are the different topics we will discuss today. So what are these? We will see one by one. A DC distributor fed at one end. Fed at one end means, so the fed means it is feeding. We can say it as feeding. The voltage is feeding at one end, and with concentrated loading we will discuss. That means if you say from A to B it is a DC distributor, A to B it is a distributor, it may be of some kilometer or 1 kilometer, 2 kilometer, 3 kilometer like that. So to this distributor we are feeding the voltage at one end, we are feeding the voltage at end A, and at different distances, so there are different distances AC and CD and DE. These are different distances. At different distances at point C a load is connected with I1 current, and at point D a load is connected with I2 current, I3, I4. So these are the four loads connected at different points of a distributor, and AC resistance is given by R1, AC resistance is given by R1, and CD resistance is given by R2. Like that, DE section, EF section, different sections are given with different resistance values. And the thing concentrated loading means the load is completely concentrated with at C with which is drawing with current I1, and at D a concentrated load is connected which is drawing I2 current. So these are all concentrated loads at different points of a distributor. So this is the DC distributor fed at one end, feeding at one end, and concentrated loading. So if you see next another case, a DC distributor, same DC distributor fed at one end, like previous one, this is also feeding at one end, but uniformly loaded. So what is the meaning of the uniformly loaded distributor? Means, suppose if you take a distributor conductor from this point to this point, so it is taken as at every regular interval, let it be 2 meters and one more 2 meters and one more 2 meters, like at every regular intervals, not irregular intervals. In previous case, the AC distance is not equal to CD distance, and CD distance is not equal to DE distance. So these are all different distances, and these are all loads at different levels, but whereas in this case, for every 2 meters or every 3 meters or every 4 meters, you can take any interval. So it is loaded with a regular uniformly loading system. Equal loads are connected at regular intervals. So that is the case of uniformly loaded system. This is non-uniformly loaded system, but concentrated loading it is. So it is uniformly loaded system. That means, so this section distance and this section distance, all distance are equal, and loading arrangement is also equal. Equal loads are connected at equal intervals. So to analyze this system, generally we will take a differential length of conductor, which is of dx, and this differential length is x meters away from the end A, feeding point A, By considering in that manner, we will analyze the uniformly loaded system, and this is uniformly loaded system also feeding at one end. It is feeding at only end A. The end B is free. It is not loaded at end B. Next, coming to next case, DC distributor fed at both ends, feeding at both ends. These are the different cases. We are initially analyzing the what are the different cases in domestic line or distributor line we are discussing. So, DC distributor fed at both ends, that means at end A, at end B, at end A and at end B, both ends the feeding points are there, the feeding points are there. Here we see voltage V is feeding at both ends, and concentrated loading, again concentrated loading means AC distance is different, D1 distance, it is D2 distance, it is D3 distance, not uniformly loading, it is concentrated loading with different loads, I1, I2, I3, I4, I5 like that. So, all the distance are different, A, C, C, D, 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 E, F, all these low distance are different, but the feeding points are at both ends. Feeding points are at both ends. This is. So, in real life, some cases comes like that. Feeding points can be taken at both ends, feeding points can be taken at one end like that. And moreover, if you see two ends fed with equal voltage, it is equal voltage feeding system. Equal voltage feeding system. Both ends are fed with equal voltage, that is, if you see at end A, voltage V is fed, at end B voltage V is fed. If you take another case with unequal voltage feeding at both ends but unequal voltage, that means at end A V1 voltage is fed, at end B V2 voltage is fed, at end B V2 voltage is fed. So, and concentrated loading in this case, that means this is D1 distance, it is D2 distance, it is D3 distance, D4 distance, and different currents are drawing, at different levels, So, this is DC distributor fed at both ends with unequal voltage, concentrated loading. Previous cases, DC distributor fed at both ends, concentrated loading, equal voltage. So, it is a DC distributor from A to B, equal voltage feeding both ends, concentrated loading. These are the different cases. And if you see another one, DC distributor fed at both ends with uniformly loaded, again like previous one, uniformly loaded means, so these distances are same, at equal distances. You can take for 1 meter, you can take for 2 meter or 100 meter, each distance may be with 100 meters, like that, equal distances. At equal distances, equal loading. The load L1 is drawing current I, the load L2 is drawing current I, load L3 also drawing current I, same currents are drawing at different levels. So, that is the meaning of uniformly loaded system. In realistic life, such cases comes, like if you see, if any serial bulbs to any functions, you can say a distributor is there, whether it is AC or DC, at regular intervals a bulb will be connected, B1, B2, B3 bulbs, regular intervals. That means at regular intervals bulbs are connected, LED bulbs or another normal bulbs are connected, that means equally loaded system it is, at equal intervals, So, for uniformly loaded system analysis purpose, generally we will take a elemental length, we will take, that means any section. If you have a complete section, if you take a small length dx and which is at x distance from the one end, then you will analyze the system. That analyzing part we will see in next session. So the analysis will be done by taking an elemental length, and moreover this system is with feeding at both ends, feeding at end A and feeding at end B, feeding at end A and feeding at end B, and with equal voltage, there may be different cases, different analysis will come with equal voltage and with unequal voltage. And if you see one more system with unequal voltage, same uniformly loaded system with unequal voltage, uniformly loaded system with unequal voltage. This is also same as previous one, but both ends are feeding at different voltage, So these are the different systems. If once again if you see, this is distributor fed at one end. First fed at one end concentrated loading, and fed at one end uniformly loading, fed at both ends concentrated loading with equal voltage, fed at both ends with unequal voltage, concentrated loading. And coming under uniformly loaded system, feeding at both ends equal voltage, unequal voltage. So these are the different cases what we have seen, different cases with diagrams. These are the schematic diagrams, single line diagrams we can say. So we covered all these different cases. Concentrated loading distributor fed at one end, fed at both ends, equal voltage, unequal voltage, fed at both voltage, equal voltage, unequal voltage, uniformly loaded, concentrated loading. So these are the different cases. So for all these cases, so we have to calculate at voltage levels, different voltage levels. That means what is the voltage we feed at V1 at point A. So we have to calculate VC, what is the voltage at D point, voltage at E point, what is the voltage drop between A and B, So if you supply a 240 volt supply here, so how much voltage comes up to here, whether it is 220 or 239, like that, how much voltage drop is happening from A to B, we have to calculate in this analysis. So in all the cases, with different loading arrangement, what are the voltage drops, what is the voltage at different levels, different nodes, that we need to calculate. So as a conclusion, in this session we covered how fed at one end system looks like, fed at both ends looks like, and what is concentrated loading and what is uniformly loaded system, and equal voltage at both ends, unequal voltage at both ends, different cases we have seen. In next session we will analyze how to calculate voltage at different levels of distributor with different loading systems and different voltage applications with feeding at one end and feeding at two ends. Thank you.